Suppose our function turns the number of whole pizza toppings into the price. Can we input 2.5 toppings? And can we ever get $9.73 if each topping adds $1? Half toppings aren't allowed, and prices land on whole dollar steps, outside the domain, outside the range. In this video, you'll learn what domain and range mean, how to find them from a table, graph, or formula, and how to avoid common mistakes. Let's start with the basics. A function maps each allowed input x to exactly one output y. The domain is the set of allowed inputs. The range is the set of outputs the function can actually produce. Think in sets. The left set is your candidate inputs. If an input isn't allowed, for example, if it makes you divide by 0 or take the square root of a negative, it's excluded from the domain. The outputs reached by arrows form the range. From a table, it's straightforward. The domain is the listed inputs. -1, 3, 4, 5. The range is the distinct outputs we actually see. -2, 1, 9. Notice that 1 appears twice as an output, but we list it once in the set. Here's a common pitfall. The range isn't every y that exists. It's only the y values this function actually produces from allowed x's. So far, we've defined domain as allowed inputs and range as actual outputs, and we practiced with a table. Think you've got it down? Head over to this link for a practice test and join the study streak, or stick around to learn more about the topic. Now, let's move to graphs. From a graph, think projections. The domain is every x value under the graph's shadow on the x-axis. The range is every y value covered by the graph's shadow on the y-axis. For example, suppose a graph stretches from x equals -2 up to x equals 4. At -2, there's a closed dot, so -2 is included. At 4, there's an open dot, so 4 is not included. That makes the domain the interval from -2 to 4, not including 4. Vertically, the graph runs from y equals 0 up to y equals 5, and since both endpoints are included, the range is from 0 to 5. Notice how closed versus open endpoints make a difference. Beyond that, there are other special cases to watch for. A hole at x equals 1 removes 1 from the domain. A vertical asymptote at x equals 3 also excludes x equals 3. And if the curve never touches y equals 0, then 0 is not in the range. Small details at special points really matter. Finally, let's apply this to formulas. Take the function f of x equals the square root of x minus 2. Since the expression under the root has to be greater than or equal to 0, the domain is all x values, starting at 2 and going to infinity. The outputs are square roots, so the range is all y values, starting at 0 and going to infinity. Now consider g of x equals 1 over x minus 3. Because we can't divide by 0, x cannot equal 3. That means the domain is all real numbers except 3. For the outputs, notice that this function never equals 0. So the range is all real numbers except 0. Here's a quick checklist to keep it simple. 1. Start with the rule or graph. 2. Exclude inputs that break the math, like division by 0 or negatives inside even roots. 3. Determine which y values actually occur. Watch for holes, endpoints, and asymptotes. In short, domain tells what can go in. Range tells what can come out. You can read them from tables, project them from graphs, or derive them from formulas by checking the constraints.
Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.